Good morning, Dave Kenworthy here. It's 10:14 on the 7th of the 7th, 2021. And we're going to look at the design of the Giza Pyramid using the measure discovered by Colonel Vyse. Because I'm sure that this is the right measure to use. And the actual unit itself is called a barleycorn. And it's here. It's 11 divided by 30. And the Giza base is a centigrade scale, and that's down here. We're going down to 100. And we're using one barleycorn, and then to get to solar year, days in a solar year, we multiply by 1,000. So there are 1,000 barleycorns in a solar year. And in the Giza base, we're going to go down here and multiply that by 100. We get to the true Giza base that Vyse measured, and it's this in inches. We're going to work out the height, which is this divided by 44 times 7, and we get that for the height of the Giza pyramid. And there are 280 cubits in that height, so we're going to divide by 280 there to get the cubit. Now you'll see a lot of things going on about cubits on various websites where people are looking at the analysis of the Giza pyramid. Some people will tell you that the ancient meter is used. Some people will tell you that the cubit is based on the ancient meter divided by a set ratio, so that you get 6 cubits when the ancient meter is multiplied by pi. Well, that's very probably true. But the way they do it gives some really, really weird cubit lengths that don't in any way conform to the way that these people did their mathematics, which was whole number mathematics. So when I worked out the design of the Giza base using Vyse measure, I got all these numbers. And they're not satisfactory, because look, 18.958333 for a cubit. That's when we're using the 91st level of the Giza base, working down from the top. So this is the actual true base length there. Now, I had to find out what I could do to get rid of these numbers, which are just not Babylonian Egyptian. And the way I've finally worked out how to do it is very simple. And I got the idea from looking at the work of John Michel, because he had this canon of ancient measure, and it was solar days multiplied by 1,000 and then multiplied by 3600 to give miles in the Earth's circumference. And what you realise here is that 3600 is a Babylonian number. And what we're doing here is we're multiplying C3, which is the Giza base in inches, when we're using 1/100th of the Giza base. We multiply it by 3600, this Babylonian factor, and we get 1320000. That's 1/100th of the Giza base length. But what we find is that actually becomes the Earth's circumference when feet are used. So that is in feet now, and we have to multiply by 12 to get it to inches. And we know there are 0.7333 inches, which is 2 barleycorns. We know there are that many in the Earth's circumference. We know that's the base 100 digit. So when we divide that into this, we get 216,000,000 units in 1/100th of the Giza base. And we also know that the Earth's circumference in ancient times could be 252 units. So this column is simply altering that to that by using this adjustment here. So these are all the adjustments across the top that we're applying to this barleycorn to get these numbers. And these numbers are all whole numbers. And we can look at them and we can see that we can discount a lot of the zeros. So we're looking at 1320 times, well, 132 times 12 gives 1584. And immediately when we start to look at this, we realise that these are the numbers that the metrologists actually end up telling us are being used. So 3168, there are 3168 0 feet in 6 miles. And when we look at this multiplied by 360, we see that this is actually the imperial system, because there's 580 feet in a mile. So when 1 barleycorn is used, we get a quarter of a mile. Well, a quarter of a mile times 1,000 in actual fact. And this is just the imperial system. That, there are 66 feet in a chain. And if you multiply that by 12, there are 792 inches in a chain. And these are all just imperial units. Now, these 4 columns are the numbers that all the metrologists keep throwing at us, but they don't really understand where they're coming from. But this model shows you exactly where they're coming from. So if we go down to this base here, it's 100 units times the barleycorn. So that's 100 barleycorns, 36.666 inches. And we multiply it by 1,000. That's the Giza base. Then we divide it by 44 times 7. That's the Giza height. Then we divide that by 280. And that's the cubit. So this column is cubits. And what's happening is, if we divide that into that, we get 1760 because of the way that this is structured. And we always know there are 1760 cubits in the Giza base. So if we divide that by 20.736, it's 1760. Always 1760. That's the way this model's constructed. Now then, what I've done with this model is I've put some cubits into it to test it, to see if it gives us any meaningful figures, because the cubit I really wanted to test is this one, 20.736, because that's the one that John Michel and John Neal are telling us is what this whole structure is designed against. And in this model you can see clearly that it isn't, because it's not giving us a whole number in the overall centigrade scale. It's giving us 99.5328. Now when we factor that out against 3,600, we get this number. And we can see here at the end that we are getting a 0 on the end. So it's a valid measure eventually when we extend it up to the 252 column. It's obviously a valid measure, but in no way is it aligning with this whole number decimal system in terms of being able to understand where it's originated. And the way that I've done this is I've gone backwards on this line. Instead of just following this starting with 100 and working across, multiplying everything out, I've put the cubit in there first. So that's what I've built up from. Then I go to multiplying it by 280 to get the height. And then I've got the base by multiplying the height by 44 over 7. Then I've divided by 1,000. And then to get this number here, 99.5328, I've had to divide by the barleycorn. So that number is 99.5328 barleycorns. And even though it's producing this cubit that John Neal and John Michel have thrown at us, telling us that this is what the whole thing's designed against, because this cubit is 12 times 12 times 12 times 12. It's a base 12 cubit. And they're telling us the design is against this base 12. And everything they've structured in their books is against this cubit. And it's not the right one. because it's just below the base 100 cubit that's derived from the barleycorn. This unit here is 99.5328 barleycorns. So my argument here is that although this is valid measure, it's in no way aligning with the design of the Giza Pyramid in terms of it being very obviously the cubit that everything else is derived from, because it isn't. And what I'm going to do is show you how I've constructed this. I'm going to deconstruct it and I'm going to reconstruct it. And the way I can do that is just by using this back arrow. So if I click that, it takes this deconstruction and reconstruction of the Great Giza Pyramid. It just puts it in, it takes the bold off it. Now it's just in ordinary letters, there's no bold. So that's the last thing I did to this spreadsheet. I turned that into bold. So if I go back again, that's gone. I go back again, and that was bold, but now it isn't. I'm going to take off this analysis. So we take that off. The bold's gone off the top. That's gone. And that's gone. That's gone. That's gone. That's gone. That's gone. And this line's going to go. The line's gone. So we're going to go backwards to see how I've designed this. So that's the last column that I produced using 252. I wanted to get this 252 number because all metrologists know that the Earth's circumference is 252 units. They also know it's 216 units. They also know it's 1584 units and 132. And that is mile. These are imperial feet, but they give us miles. So we're going to go back and gradually see how this has been done. So that column's gone. That column's gone, 2160. That column's gone. We can see how the model is being built up here. And everything's been worked out column by column. This is where I've used the 19.8 inch cubit and I've put that in back to front. So let's have a look at it again. Let's go back. The 19.8 cubit, which is the one that Berryman tells us is the Sumerian cubit, is giving us these numbers, and 95.04. So it's valid, but it's not giving us a whole number here. So it's not part of the original simple construction based on the barleycorn. It's based on a fraction of the barleycorn. It's not based on whole barleycorns. So we go back and go back again, go back again. And gradually we can see I've used 20.62 as a cubit and worked backwards, so we can go back and we can see 20.62, which is one of Petrie's cubits. We can see that that's 98.976. Again, it works out as a valid cubit, but it's not giving us a whole number in this column. So part of the simple original overall design of the pyramid is this first column, and that's obviously fractionalizing the barleycorn, and that number there is this one divided by the barleycorn. So it's producing a fraction in there. So we know that although it's a valid unit, it's not following the original simple design. So we go back and we'll get now to this one that I originally dropped in, which is this 20.736 that I've already talked about. And there it's gone now. And we've just got the basic simple design. Now what I want you to look at here now is that The base 100 design that I talk about all the time is given a cubit of 20.83. The base 99 is given a cubit of 20.625. That's Berryman's Egyptian Royal Cubit. And the base 96, excuse me, base 96 line is given as a cubit of 20 inches. And it's giving us a height of 5,600 inches. And that's really, really in line with our expectations of using 44/7 and what it produces. If we use 20 inches, then we're getting these whole numbers. And we're getting whole numbers when we use 90. Because when we use 10 in there, it's going to produce some really nice whole numbers. But the cubit itself is 18.75 in that instance. And this cubit is reducing all the way to the top, to the top of the pyramid. And that's a cubit at the top of the pyramid. This is the first calculation where we're using one barleycorn of 11/30 inches. Then we're multiplying it by 1,000 to get the Giza base of 366 inches, 366.666, and the height is only 58 inches. So we can obviously go down to a half, a quarter, an eighth, and just carry on getting smaller and smaller as we get to the top of the pyramid. But that is 1/100th of a cubit, because that's 1/100th of the overall height of the Giza pyramid. And it's very simple using this system, and it produces the imperial system immediately that we start to multiply by 3,600. So let's go back and see if we can figure out how this all started. So we click on the forward arrow and we're going to put in this Michel and Neil cubit, 20.736. These are the associated calculations in reverse. I made a mistake there, and there it is, 99.5328. And then we carry on and put in another cubit in now, 20.62, and we go in the reverse. You can copy and paste that. And that turns out to be 98,976. And now I'm dropping in this Sumerian cubit, 19.8 inches. And that's 95.04. And then we go to the top, where we're multiplying 366.667 by 3,600. And we're producing, this is feet now, we're producing. And we go again, and that column is completed. We go again. I've widened it so that we can get all the long numbers in. Go again. Multiply by 12. Column completed. Go again. Divided by the digit, which is 2 barleycorns. And we get that number. The column's completed. Go again. And we got this 252 number that everybody knows the ancients used to work out the circumference of the earth. So we complete that column, and that's the whole thing completed. And now we put the notation in across the top, what we're using, how we get to all these figures. And I've explained all these now, we know. And we're building up now, put a title in bold. We'll bold up the headers. And then deconstruction and reconstruction of the Great Giza Pyramid. And that's it, because that's gone blank now. If I go back one, it'll be dark. And we go back again, and it's... I'm not sure you can actually see that. No, you can't see that on the screen, but never mind. And now I'm just going to work out the Earth's circumference in miles. And the way we can do that, The way we can do that is just divide by 528, or this column here. So that represents 250 miles. We go down to the Giza base and we get 25,000 miles as the circumference of the Earth. And to prove that this system is working exactly as it should, we get this number here that Michelle and Neil tell us is the root of ancient measure, 24883.2. That's the meridional circumference of the Earth in their system. We can clearly see here that it is not the full system. It's 99.5328% of the base 100 value. And that is why we cannot rely on the work of Neil and Michelle to give us the full picture of what is happening within the design of the Giza Pyramid. And that's it for now. Cheers, thank you.